Hello guys. So today we are here to solve this our daily Leetcode challenge problem, can place flowers. In this problem we are given an input array and an integer n. We need to find out whether we can place n number of flowers in this input array n, which is denoted here as flower bed. The condition is that wherever you place the flower, its adjacent side should not be containing any flowers. So in this case, see, for this example, in this case, ones represent flowers and zeros represent the non-flower spots. So here we can place one flower here, and then n is, one flower we can place here. So, we can easily meet the condition of this problem, and we can place this n is equal to one flower at this spot, because this spot is not a flower spot, and this spot is also not a flower spot. So flower can be placed only in this spot. So with this, we are able to solve this problem. Now, in this, see, in this example, the second example, in this n value is 2, so we can place one flower here, but will not be able to place any other flower because this one is occupied by this flower. So this spot, we cannot place any flower. And we have already placed one flower here, and we cannot place any flower here. So n is equal to 2. For this, we'll have to return false. So very simple problem, and just simple logic we have to apply. So let's see, how to do this problem. So if suppose flower bed dot length is equal to 1 and flower bed of I 0, length 1 is equal to 0, then return n is less than 2, then we are able to meet this. Now in the second case, let's have one for loop. For int I is equal to 0, I less than flower bed dot length plus I. So see, there are three cases here. So what are the three cases here? So let me demonstrate the three cases here. Suppose we have this one flower pot, and we want to this spot is not occupied. Yeah, so suppose this spot is 0 and this spot is also 0, so we can make it 1, and this will, since both of them are 0, then we can do it. And suppose at the end also this spot is 0 and this spot is also 0, so we can place one flower here. Otherwise, barring these two spots at the front and these two spots at the back, wherever we have a spot which contains 0, which is surrounded by two zeros, then we can put one, one surrounded by zeros. So this is the condition here. Okay, so it's easy, and we will be able to do this. So with this, let's start going back to our problem. So in this now, so if I is equal to 0, and so let's first put one condition here, that if flower bed of I is equal to 0, so everything will be considered only for that case. If I is equal to 0, if I is equal to 0 and flower bed of I 1 is also 0, then in that case we'll make flower bed of 0 is equal to 1, decrement n, and if n is less than equal to 0, will return true. In other cases, if I is equal to 1 if I is greater than uh, I is greater than equal to 1 and I is equal to less than I is, so we can make it I is greater than 0 and I is less than flower bed dot length minus 1, and if I is greater than 0, I is less than flower bed dot length minus 1, and if in this case flower bed of I minus 1 and I minus 1 is equal to 0 and flower bed of I plus 1 is equal to 0, then what we'll do that we'll make flower bed of I is equal to 1. Again, we'll decrement minus minus n, and then we'll just put this condition. So we'll take this condition and put it here as well. Now the third condition is that if I is equal to flower bed dot length minus 1 and flower bed of I minus 1 is equal to 0. So again, in this case, we'll put same these conditions. Okay, and again when we come out of this loop, we'll put a check. If n is greater than equal to 0, return true, else return false. Okay, so let's run it. Perfect. So in this way we can solve this problem. Let me know if you have any doubt. I'll happily answer those doubts in the comments. So please put all of your doubts in the comments and I'll answer them for sure. Thanks a lot.